Hi, chemistry students. Mrs. Grote here. I just want to review the measuring gases review, the front of this handout, just so we can get started on doing some problems moving forward. So there's a lot of different variables we're going to have in this unit. Temperature we've seen before. The big thing is it's always going to have to be in Kelvin. Amount is going to be in moles. So if they give you grams, you're going to end up converting to moles. Volume, it could be milliliters, it could be liters. In this example here, there's only liters as a choice. And then the variable that we're going to see the most different units is going to be pressure. So we won't see newtons per square meter. If you take physics, you might see that one. Pascals is the standard international unit, kilopascals. Atmospheres, PSI, pounds per square inch. That would be a more common English unit, like you might see that on your bicycle tire. Millimeters of mercury, inches of mercury, you might hear if somebody's discussing the weather. So we need to recognize the different variables. Okay, so we're talking about weather here. So if you're seeing a falling barometer, that means the pressure is falling, and that usually is going to indicate that there's a lot more water vapor because water vapor is less dense than air. If you think about the molar mass of water, it's 18. It's a lot less than the molar mass of oxygen and nitrogen, 28 and 32. So that's why low pressure is going to have a falling barometer. And usually, if a lot of water vapor in the air, it's going to be raining. Now, this question about toxic metal. So barometers have mercury, and that's because mercury is very dense. And that density is going to make the column a lot smaller than if it was filled with water. So the density of mercury is 13. The density of water is 1. So we're using mercury, so we only get a very small change in the height of the column. Okay, atmospheric pressure. You saw the one slide on the PowerPoint. It's the weight of all the gases. So if you think above your head, all those gases in the atmosphere, that is what causes pressure. And then finally, that last question, it's a really good question, and I hope you tried it. 2 balloons are filled with helium in a classroom. One is filled to a volume of 2 liters, the other to 4 liters. In which balloon are the helium molecules moving more rapidly? So speed, that's temperature. Kinetic energy is another word for temperature. So if they're both in the classroom, they're both going to be at the same temperature. So if they have the same temperature, they've got the same kinetic energy. So even though there might be more molecules in the larger balloon, it might have more collisions, but it doesn't make the molecules travel any faster. So that's it for now. Please correct your answers as we have gone through. You're going to be finishing the back of this handout as an assignment tonight.